LWDM isn't as well known as, for example, CWDM or DWDM, but there's also a big difference in how they were actually specified. For CWDM and DWDM, for example, the number of channels in each individual grid were actually specified right from the word go. But with LWDM, that wasn't the case. It actually evolved over the course of time and the number of channels increased. If you want to find out why that was and also what LWDM is used for, stick around and we'll check it out. LWDM was originally specified for the usage in transceivers. To be more precise, the first 100 gig LR4 transceiver that IEEE, Finisar and also a larger group of supporting companies were actually working on. Now, the biggest challenge at the time was that it wasn't really possible to have higher data rates than 25 gig per electrical lane. And that's why the idea actually came about to use optical multiplexing inside a transceiver. And that's when the first 4 LWDM channels were specified that you can see here. Now the obvious question is, why didn't they just use 4 CWDM or DWDM channels at the time? After all, those grids were already specified. Well, there were technical reasons why that wasn't possible. And the first reason being, the requirement was that the channel spacing had to be very narrow to minimize dispersion differences between those 4 different channels. And the channel spacing of CWDM simply was too big for that. Now, of course, we've got DWDM, dense wavelength division multiplexing, and that has got a very dense channel spacing. But there was actually another reason why DWDM couldn't be used, and that was it actually isn't possible to build the optical multiplexers in that DWDM range as small as you can in the 1300 nanometers area. And after all, these multiplexers had to be built into transceivers, so they had to be as small as possible. Therefore, DWDM could also not be used. Now back then, HUBER+SUHNER Cube Optics was already very well known for designing and building miniaturized optical multiplexers. And that's also the reason why our experts were actually brought into that working group to prove that it was possible to make the miniaturized multiplexers for that new LWDM grid. As I initially said, the LWDM grid actually grew over the course of time. And the next thing that happened that led to more channels being added to that LWDM grid was actually when we started talking about the LR8, so the 200 and 400 gig transceivers, which used 8 optical lanes. And it's actually not too long ago that the ITU published a specification for LWDM containing 22 channels that you can see here. But it's important to know that actually at the moment we mainly only use 12 of those 22 channels. Since LWDM is mainly based on 25 gig per lane, there is actually quite a nice idea how it can be used for 5G mobile applications. And the idea is to have at the baseband unit a 100 gig interface where you can use an LR4 transceiver, and at the cell side you then can actually have a passive optical multiplexer and demultiplexer to separate those 4 lanes. And since 5G radios actually have a 25 gig interface, you can connect that directly to the radio heads. Quite a nice idea, isn't it? Now, there are many things that I've found out about LWDM, but one thing I actually couldn't find out, and that is, why is it actually called LWDM? I know that it's called LAN, so as in local area network WDM, but why local area network? If you know, please leave it in the comments. So, I hope you learned something today and that you enjoyed this video. If so, please also leave a comment. Until then, see you next time. Bye-bye.